All right, so I want to give you some examples of how we name ionic compounds. So recall that with a ionic compound, we are always talking about a metal and a nonmetal. Okay, and those the metal part and the nonmetal part form ions, which are charged. The metal will be charged positively, that's your cation, and the nonmetal will be charged negatively, that's your anion. When those join together, they make a compound, and that compound has a neutral charge. So the charge from the metal has to balance out the charge from the nonmetal. Okay, so let's take a look at some examples. So I have the flow chart that I put on the Canvas site. And right now we're just going to worry about this one side of the flow chart. We're not doing the nonmetals only. We're just doing the metal and the nonmetal. And as a matter of fact, for this particular chart, I want you to have this chart because we'll use it later, but we're just going to go one side of this chart. And where it says, does the metal form only one type of ion? In the case that we're talking about, yes. So we're going to be on this side. So when we name ionic compounds, metal and a nonmetal, and in our case, it's going to be one type of charge on the metal. Okay. All right, for our first example, we're going to look at the compound, the ionic compound, barium oxide. There's the name. So let's look at when we're given this as a chemical formula. I see Ba and O. And what I know is if I look at the periodic table, I have barium is group 2. So if it's group 2, 2A, that means that barium's going to have a plus 2 charge. So barium is 2 plus, and this is more not so much for the naming, but just to get used to what is forming that ionic compound. Barium is 2 plus, and if I look at oxygen, it's in group 6, 6A, and elements in group 6A form 2 minus. So I have oxygen and barium. It's composed of those two ions. So remember, when we write the formula, we do not write the charges. We just write the formula as this, but we imply, because we know it's ionic, that there are charges in here. All right, so the first thing we look at when we look at our formula is what is the metal, what is the cation, and what is the anion. The metal is barium. So if you look on the periodic chart, that's in the metals. And the nonmetal is oxygen. Okay, so we have the cation and the anion. We have the charges from both of those. We don't need that for the naming, but it's good to get used to doing that. So how do we name this? We start with the name of the metal. So we're going to call it barium. I'm just going to write over this because I don't have much space. Barium. And then we name the root of the anion. The anion is oxygen, so the root is ox. And we add IDE. So the root of the anion plus IDE. So barium oxide will be the name for this compound, barium and oxygen. All right, for our second example, we have an ionic compound formed between potassium K and iodine I. All right, so potassium. Potassium is in group 1, so that's our metal. We want to look at what's the metal, what's the nonmetal. Potassium group 1 is our metal. Iodine group 7 is our nonmetal. So we know that this is composed of K plus because it's group 1, it forms plus 1 ions, and iodine group 7 forms minus 1 ions. So our compound is balanced between 1 plus and 1 minus. So the compound itself has no charge. Okay, so now we just name the metal, potassium, and we name the root of the anion, which is io, and then iodide. So when we write our name, potassium iodide. All right, for our third example, we have AlCl3. Okay, so that is an ionic compound. We have a metal aluminum and chlorine, which is a nonmetal. That's our anion. Okay, so we start with aluminum. Aluminum is in group 3A, so it's going to be made from Al3 plus. Chloride is in group 7, so it has a 1 minus charge, Cl minus. So I need 3 chlorines, 3 of these negative charges to balance the positive charge. So in my formula, I have AlCl3. When we name the compound, we're not concerned about that. We know that that must be the case. We just want to give the names of the different portions of the compound, so the metal and the nonmetal. So when we name this guy, we're going to name the metal aluminum. We're going to name the root chlor, and then instead of ene, we say ide. So this compound, AlCl3, is aluminum chloride. Okay, so we don't need to specify there are 3 chlorines. It's implied because we know it has to have 3 because we need 3 chlorine minuses to balance the 3 plus charge on the chlorine. All right, for our final example, we're going to name this compound between magnesium and nitrogen. All right, let's just name it right off the bat. So remember, we don't care. Magnesiums are metal, nitrogens are nonmetal. So we don't care, in this case, we don't care how many of these we have as far as the name is concerned. So for this compound, we're just giving the metal its name, magnesium, and the root of the anion, nit, and IDE. So nitride. So magnesium nitride is what this compound name is. Now, if we want to get detailed about what is this compound made up from, let's look at where magnesium is. Magnesium is group 2 on the periodic table, group 2A. So magnesium is 2 plus, and nitrogen is group 5A, so it is 3 minus. So the compound itself is made up of magnesium 2 plus ions and nitrogen 3 minus ions. Okay, to combine those together to get a 0 charge, I need 3 magnesiums, so 3 2 pluses, and 2 nitrogens, 2 3 minuses. So for that, we're getting into the next topic, but we're going to have plus 6 from the magnesium, minus 6 from the nitrogen, neutral compound. But as far as our naming is concerned, we're not worried about that. We name the metal, magnesium, we name the nonmetal, nitra, and we give it the IDE, so magnesium nitride.